start in a couple of minutes so that more people can join and then get advantage of the next session.
Am I audible?
Yes, sir.
Yes, sir. You are audible. Okay, so shall we start the session?
Yes.
Dr. Tapan, shall we start?
Yes, yes.
Okay, thank you for joining, Dr. Tapan. Mr. Kundan, can you please introduce Dr. Tapan?
Yes, ma'am. Yes, ma'am. Good afternoon, sir, and all. It is great pleasure for me to introduce our speaker, Dr. Tapan Kumar Jain, who is going to talk about us KNN and its application. Dr. Tapan Kumar Jain is working as a head of department in electronics and communication engineering in Indian Institute of Information Technology, Nagpur. He is also institute coordinator of post graduation and PhD program. He has approximate 18 years of industrial as well as academic experience. He is a senior member of IEEE and in 2020 and 21 he has conducted 5 academic faculty development program on IoT and machine learning. He has a close to 30 publications in international conference and journal also. He is a research area compromise of wireless sensor network, IoT, image processing, AI, ML, and data science. Currently, he is a guiding 6 research scholars in the domain of wireless communication and signal processor. Now, please welcome in Dr. Tapan Kumar. Thank you, ma'am.
Okay, so thank you, Mr.
Thank you,
Kundan,
Kundan.
for
Welcome.
Yeah,
generous
thank you, Dr. Tapan, for accepting the invitation for giving a talk on KNN. Thank you so much. Over to you, sir.
Thank you. So, very good afternoon to one and all present here. And in this particular section, I'll be covering the supervised learning, and especially in supervised learning, I have to talk about the key nearest neighbors. And why I choose this KNN, because it's very easy. Those who are very new for this particular area, right, they can very easily apply this KNN, right? So it is very easy to work. Right. So I hope everyone is much aware about the supervised and unsupervised learning, right? So now my question is very simple. I'll ask one question, right? If my data is categorical, if my data output variable is categorical type, can we apply supervised learning in the form of KNN? Or can we apply linear regression, or can we apply logistic regressions? So anyone can give me answer. If my output variable type is categorical, can I apply KNN? You feel free unmute your mic and just tell me if you know, if you don't know, right? Because I want to make it the session interactive. Okay, so in my upcoming slides, I will be explain what is the data type, what sort of statistics is involved in the supervised learning, right? And then we'll try to cover this KNN algorithm in this particular sessions. So whenever we apply the machine learning, number one question in our mind is my data is the labeled or not? As you know that this is a supervised learning algorithm, right? KNN is one of the supervised learning algorithm. So you can only apply for if my data is labeled, right? So what do you mean by data is labeled? Data is labeled means what is my output type, right? So let's start with very basic, right? So whenever we start the machine learning, so we have the data in a different format, right? And if we talk about, suppose I have a data in the Excel sheet, right? So in an Excel sheet, if you look at carefully observe the Excel sheet, then we have rows and columns. So what do you mean by these columns? Column is nothing but you can say my input, or you can call as my features. You can call as the features, either input or you can call as the features, right? And one of the last column, if my data is labeled, one of the last column, it will give you the what is my target, or you can say what is my outcome, right? Outcome, or what is my output, right? So this last column, if you have the target variable or if you have output or outcome is specified, that means you can see that my data is labeled. And this data is basically is in two types. One is in the numerical data and another one is a categorical data. Another one is the categorical data. Numerical, again, we can split into the, can say, discrete and you can say continuous, right? So for example, if you doing the programming, so you know that the data type, and so we can use the value like for discrete we use always the count value and you can call as the integer, and for the continuous value we can use the float. Okay, so number one, this output variable is divided into, you can say data type is divided into two types, numerical and categorical. And numerical is again divided into two parts, discrete and continuous, or you can say the count. So for example, right, for example, average wind speed in last 1 hour. So it's a count, it's a continuous value. It is a floated value, right? And let's say the second example, suppose I have, I'm working in a call center. So number of calls received in a day, number of calls received in a day is a number, is an integer quantity. But the duration of each call is a continuous one, right? So first we have to distinguish the data type. It is not correlated directly with, you can say the integer float, but every language have the different data types. And then when we apply these programming concept, so how efficient you can fetch the data, right? That's why we studied that data types. Then the categorical, you know that we normally categorize into the binary format. Binary format means whether my output is present or absent, whether the customer is default customer or not, whether um, you can say that the gender classifications like that. So we have the fixed number of bins, or you can say buckets in the categorical data, right? So this may be more than two, right? So in the special case, if only the two bucket is there, you can say that the binary, right? We have more number of buckets in some of the applications, like we want to differentiate our mobile phone with respect to operating system. So some of the user uses the iOS, some of the Android users, some of the smart users are Windows, and fourth one is the other category like that. So we divided the smartphone based on operating system in the 4 buckets, right? Similarly, the spatial type is binary, whether my operating system is Android or not. Sometimes this categorical is useful when it's in order is matter. Order is matter. Order is matter Parameter means when I, take the feedback. So if you look at the feedback, there is a, 5 radio buttons, right? Or 4 radio buttons. Their order is very important. 5 is represent for, you can say excellent. And 4 is represent the very good. Third is represent the good. Second one is represent as average. And first one is poor. So this order is fixed. 1, 2, 3, 4, 5 order is fixed. If I ask, give the rating, so you don't change the sequence. Here the sequence is fixed, right? So number one in the supervised case, first my data is labeled. Labeled means this output column having some values, target values or outcome, right? Then the second step is we have to identify what is the type of output variable. Because if you know the type, then only you can apply the particular algorithm. So for example, if I want to apply linear regression, so linear regression is only applicable for numerical data, whereas logistic regression is applicable for categorical data. In morning session, you have heard about the decision tree. A decision tree is very good. It's applicable for both numerical as well as category. Like that. Then if you go to the Excel sheet, we have number of, this rows. Rows is nothing but your records, or you can call as the samples. Record, or you can call as the samples. And always remember, when you apply the machine learning algorithms, always a row value is very much greater than the column value. Make sure, right? So some of the students, they have only very few records, let's say 50, 100, and they try to apply the machine learning algorithm. Machine learning algorithm is only suitable for huge data, large amount of data. Otherwise, what happened if you have only 50, 60 data, and whenever you have provided the new input or new data points, your system is unable to differentiate, right? So more number of training is required in case of machine learning algorithm. It is not the traditional program, right? So now I hope it is clear. You have the input, maybe a structure or maybe a non-structure format. Like in most of the time when we do the, when we apply the machine learning algorithm, always is in the rectangular format, right? Where it consists of rows and columns. Rows known as your records or samples, right? Where column known as your inputs, or you can say the features. And in supervised learning, the last column is your output or target or outcome. So you are able to say that my data is labeled. And again, this is a data type. You can assess this column, maybe a numerical data type or maybe categorical data type. And based on that, you go for either supervised learning or unsupervised. So data is labeled supervised, data is not labeled, going for unsupervised. Right? So this is just one, introductory step. Second step is in machine learning, basically our aim is what? We have to increase the accuracy, right? Or you can say reduce the error, whatever. Okay. So you have to make a very efficient system. So, right. So efficient system is depend upon, right, the algorithm selections, number of records, right, and your system capabilities, right? Okay. So we will discuss in detail in our, in this algorithm. Any doubt, you can feel free, unmute your mic in any point of time and you will ask the question. Okay. Second thing is our aim, as I mentioned, that our aim is to, increase the accuracy. And the second point is we have to decrease the error. Okay. So for that, we have to use some, some statistical operations, some statistics. So you should have a little bit knowledge of the statistics as well when you start working on the machine learning algorithm. So I hope everyone should aware about this mean, mode, median, deviations, error, 50th percentile, IQR, right? So deviation, standard deviation, and variance, right? So you all aware about this number one step is mean, right? And the second one is the mode, third one is the median. Right? So mean, mode, median. So mean kya? Nothing but you have, n number of samples. You can sum up the n number of samples, right? And divided by n. This is a simple mean. But in this case, we have used two different types of means, right? So one is the weighted mean. One is the weighted mean. So weighted mean is what basically, suppose in my room, I deployed some, temperature sensors. I know that I had, maintained the temperature, it's let's say 26 degrees. I know that my all the sensor is working fine, but when I take the reading, the sensor will give you, reading somewhere around 25. The sensor will give you the 24. One sensor will give you the 27. Another sensor will give you the 25.9. Some is 26, like that, blah blah blah. So every sensor, I know that my room temperature is, here it is 26, but the reading is differ from some 1 degree or 2 degree, right? Plus minus 1, 2 degree. So why? Because in every sensors, equipped with some electronic, instrument or devices. So maybe the amplification factor of every sensor is different. So we do one thing for these kind of applications. When you extract the data, we can do one thing. We have do the some kind of calibration. So x1 multiplied w1 plus x2 multiplied w2 plus all the sensor value divided by total weight. So this is known as your weighted mean. So we usually avoid this normal mean. We use the weighted mean, number one. Second important concept in this case is after weighted mean as the trimmed mean. Trimmed mean. Okay, so what do you mean by trimmed mean? Trimmed mean is basically I need to, find out the average marks of my past student in my class, right? So average marks, how do we calculate this average marks? My past students. So I know that the highest is maybe 100 marks, and for the passing in my subject, maybe a minimum marks is 30. So every student with the range of 30 to 100 is, pass a student. Otherwise, you have a fail student. So when I enter into the Excel on some software, right? So by default, if I type value, let's say 110, right? 141. Or by default, I'll take the, some fail student value, let's say 29, let's say 20. This is not my range. Range means minimum to maximum, within minimum to maximum. So we discard these values. We discard these value and then only find out the mean. That is known as the trimmed mean. It's very, very important. It is very, very important in trimmed mean. Right. So sometime we do, intentionally we do the trimmed mean. So for example, I want to calculate the average salary of my employee. Let's say, we'll take the example of, let's say, Microsoft. Let's say example of Microsoft. I want to take the average, salary of Microsoft employee. So if you go for Microsoft employee, we, intentionally, reject the higher positions employee like Satya Nadella. We can, like core members, Bill Gates. We, discard these salaries and then only we'll able to take the average. Otherwise, what happened? Their salary is very high as compared to the average employee. Their salary is very, very high, right? So that we avoid this normal mean, we go for trimmed mean. Similarly, we have, trimmed median. Median is nothing but we arrange all the values in the ascending orders and then the center value. And the center value is right. So we arrange the, ascending order, the center value is our median. So we also apply the weighted median or trimmed median. Mode is what? Mode is what? Highest number of frequencies. So suppose I have sample 2, 2, 4, 5, 6, 2, 8, 7, 5, 4, 3, 1, 1, 2. If I calculate the mode, so this is a frequency, highest number of frequency of sample is your mode. Like that. A very interesting question is what is the difference between the robustness and outlier? कोई बता सकता है? Anyone can tell me what is the difference between the robust and the outlier? Anyone? Okay. So I'll give you one example. Okay. So in the previous example of passing my, pass student range. So it ranges, let's say 30 to 100, right? And if you observe that by mistake, I enter the 140. So is this an outlier? Number one. Second example of temperature. Very good. I got the couple of answers. Right. So we'll discuss it. Thank you for your response. Right. Second is the temperature. So most of the, temperature value is 22 to, let's say, 29, and one of the sensor value is, let's say, 40, and one of the sensor is, let's say, value is 70. This is the one example. Right. The third example, this is your past student problem. This is your temperature problem. And now come to the average quarterly or average monthly balance in the saving accounts of my employee. Let's say somebody has, 1,000 rupees, somebody has 10,000 rupees, or if average salary is, let's say in my organization, it's 70K. So most of the employees have the, 60 to 80K. Some of have the good saving that they have the 5 lakh rupees, and one of the employee having the 50 lakhs rupees. So in first case, if you clear, because we predefined our pass out student range. So this is the absolutely correct. One of the participants give the answer is the unwanted or undesired signals or samples. So this is the outlier. We know that the, in some case, maybe this 40 is maybe possible in, in the temperature, but this 70 is not at all possible, right? So this is also outlier. But in case of the saving account, this is not the outlier. This is not the outlier. Why? Because your system is so robust to handle these high value as well. Of course, there are some kind of check is required, but that is not the outlier, right? Some kind of check is also, so the banking person will observe that how this, the transaction is very high. What is the source of this particular fund? That check is required, but it is not, I don't have, 50 lakhs in my account, right? Maybe I, sell my small flat. So somebody is, buyer maybe deposit this much of amount. So this is not the outlier. This is your system is too robust to handle these values, right? So I hope now it is clear, everyone, what is, robustness and so Durga Devi Veluswamy. So outlier outlier is a sample having value deviation from rest of the sample. So okay, that may be correct, but it is also there is a slight division between robustness and the outlier. Okay, that is answer is correct. Then Mr. S. Sivakumar sir, outlier helps to filter out the unwanted value from data set that does not contribute to the classification. Okay, that is absolutely correct. Thank you. Okay, now any question in this point of time? Any question? Okay, thank you. So today we'll talk about, discuss with K nearest neighbors, and in, what is K nearest neighbor? How do we apply the K nearest neighbor? How to calculate this value of K? And we'll take one or two examples, right? So I'll be, just complete it within, next 25 minutes. I'll try to complete this, and we'll take the questions. As I mentioned that it is a one of the, supervised learning algorithm, and also the lot of, variants or different nomenclature you can see the available for this KNN. It is also a memory based reasoning or example based reasoning, instant based learning, or lazy learning. Why it is called instant based? Because whenever the new data point is come, let's say for example, this is our complete set, right? This is my data set. When the new data point is come, this is our new data point is come. It has to create the, it need to create the instant for all the data points. So every data point he needs to create the instant. So it requires a lot of memory, right? You just need to create instances. And whenever the new data point is come, it takes a lot of time to create the instance for all remaining data points. So that is why it is, lazy. So large computational time is required in case of KNN, but it is very easy to apply. As I mentioned that it is one of the simplest supervised machine learning algorithm and mostly used for classification It classifies the data point based on how its neighbors are classified. So as I mentioned, that mostly used for classification. That means my output variable type is a categorical. So please keep in mind these answers, small answers. It's very easy to apply in your existing database. A powerful classification algorithm used in pattern recognitions. Why? Because as I mentioned that whenever the new data point is come, you need to create instances. Whenever the instance is match, that means you match the pattern. So it is a powerful algorithm for pattern recognition. This k nearest neighbor store all available cases. As I mentioned, then why it is stored the all available cases? Because whenever the new data point, it's create a new instance and save into the memory. And it's classified based on the similarities. Ab similarity kya hai? What do you mean by similarities? Right? So similarity maybe, you can find out the distance, Euclidean distance. You can calculate the correlation coefficients. You can calculate the similarity coefficients like Jaccard or Sorensen's, right? So, but most of the time we prefer the distance function, and you all aware about the different, distance functions as well. And you all aware about the Euclidean. You all aware of Euclidean distance, right? X1 minus x2 square plus y1 minus y2 square and under root. Second, you also aware about the Manhattan. Instead of Manhattan, what happened? Manhattan, instead of this square, we use, modulus value, x1 minus x2 mod plus y1 minus y2 mod, like this, right? There are some other method also to calculate the distance, like instead of this 2, I can replace with this q, and we'll take the, 1 by q, cube root of this, like that. Okay, so like there are so many, you can say the similarity major coefficients available. It depends upon your application, but for most of the time we prefer the Euclidean distances. One of the top data mining algorithm used in today, as I already explained, there's a non-parametric lazy learning algorithm, right? Now let's see this example and try to figure out, this green data point belongs to which particular class, right? So before start that, we in k means clustering, k nearest neighbor, we first define the value of k. So the k is equals to in both the cases. So for example, first this particular case, I will take k is equals to 3. I'll tell you how we can define the k, but now initially we assume that k is equals to 3. 3 means whatever the property you have to find out. So suppose in this particular figure, I need to find out this circular one, green color one belongs to which class, A class or B class or red class or blue class or rectangular class or circular class, whatever. Right, so I initially define the value of k is equals to 3. When I define this, so number one step is you need to find out the 3 neighbors. You need to find out the 3 neighbors. Right, so based on equivalent distance, I immediately find out these my 3 neighbors. So if you look at that, this green color circular will show you the nearest three neighbors. Number one. Once you identify these three neighbors, you need to perform a voting. Voting means out of three, two are belongs to this B and one data point is belongs to the A, right? Or vice, or you can write two are belongs to the circular one and one is belongs to the rectangular one, or red one, two is belongs to the blue color and one is belongs to the red color, like that. Okay. So once you make this table, you clearly shows that the majority of data points is look like a blue color or circular or B. So this green color, my new data point, this green color is also belongs to this particular category, majority of the category. Majority is what? Either blue, B or circular, like that. If, for example, in this case, if I take K is equals to 7, can anybody tell me what is the green color? It belongs to either red or blue. Can you tell me the answer? So first I take K is equals to 7. That means I need to identify the 7 nearest neighbor of this green color. This is 1, 2, 3, 4, 5, 6, 7. So this 7, if you look at that, 7, 5 are belongs to the red category and 2 is belongs to blue category. So obviously this green one is belongs to the red category. It is very, very simple. This is very, very simple. Any confusion, any question? How do we find out this? Based on the equilibrium distance. So abhi mujhe kya karna hai? I need to calculate the equilibrium distance from this green color to red color distance. And first I need to calculate for all because I have to create the instances. Then I have to arrange this distance in the ascending order and I need to just capture only the 7 because I have predefined K is equals to 7. So I need to identify only 7 nearest neighbors. Okay, I hope it is clear. Now, the value of K, how do we choose this value of K? So K in KNN is a parameter that refers to the what? Number of what? Nearest neighbors. Number of nearest neighbors include in the majority voting process. हमने क्या किया था? Then after identifying the nearest neighbor, we perform a voting, right? So K is nothing but the nearest number of neighbors. Okay. Second point is, now instead of second point, we'll just move to the point number 5 because हमको इसमें voting करनी है, right? So to avoid the confusion or to avoid the selections, we always, assume K as the odd value. So in previous example, I assume that K equal to 3 or K equal to 7. Why? If I take K is equals to 4, right, and both the category is, belongs to two boards, so it create the conflict. So to avoid the conflict, in the case of KNN, we always prefer K is your odd value. K is your odd value, right? Number one important point is K is odd, right? This is very, very important point in K. Second is if k is too small, agar hum 1 rakhenge, let's say, so whatever the nearest neighbor, it automatically inherits that property, right? So sometime if the wrong data point or the noise point come into the picture, it will always take the noise point value. So k is equals to 1 is not at all possible because it's too small and very sensitive to the noise point. So the minimum value you can say that. So minimum value you can say that, right? K equals to 1, it's not possible. K equals to 2 is what? It is an odd value. So the minimum value of k is 3. So odd number 1 and then minimum value is 3. Right. Now third question is, larger the k works well. If k is very large, right? But the problem is if the k value is very large, a lot of computational time is required. And you have to stop this process because as I mentioned that machine learning is applicable when you have the huge number of records with 10,000, 20,000 or lakhs. So if k is very high, because every point create an instance, it required a lot of memory, right? Lot of instances, large time computational complexity, right? So in the literature, the maximum value of k is, this is a third point. Maximum value is square root of your sample value. So sample value, let's say, for example, I have n is equals to 10,000 samples. I have this is 10,000 samples. So of course, this k is not greater than 100. So you can choose the k in between 3 to 100, right? Because we already defined the minimum value of k is 3, maximum is 100, and it is always to avoid the confusion on conflict, choose a odd value, right? So this is the overall, how to choose the k value, right? So I hope it is clear, right? How to choose the k value. Any question, any problem, please let me know. Any confusion? Anyone, any difficulty, just let me know. Okay. I'll move further. Thank you. Okay. This point we have already discussed. The data is labeled. Data is noise free. Basically, it is a job of not the, this is a job of your EDA. All right. What happened when we have number of rows and columns, right? Some of the value is missing. In some of the rows, some of the value is missing. Right. So we discard these rows. We discard these rows or delete these samples, and then data is a small. Why I am saying the data is small? Not small means not the 10 or 20. Small means less than or less than 1 lakh kind of thing. So it requires less computational time, right? And if the data is large, of course, accuracy is high, right? We'll take the very first example of KNN, right? And KNN. So can anybody tell me how many features in this example? Anyone? Please write into the chat box. How many features in this example? Okay, I got one response from, I hope, Durga Devi ma'am. Then I have, second response for Ajay sir, Shivakumar sir. Okay, fine. 5, 4, 4, 4. Amit sir. Please, those who have not able to write the answer, please write the answer. Please guess. If you don't know, please guess whether it is 3 or 4 or 5 or what. So I'll give you the, okay. Abji sir, okay, I got answer 3. Okay. Okay. So suppose I have a, thank you for your response. So so suppose I have an Excel sheet, right? So in Excel sheet, if I, write the serial number 1, 2, 3, 4, that is not the, features or name. That is not the features, right? Name, right? This is not the features, right? So this in the first column, this customer is not at all the customer name, is not at all the features. Okay. Okay. So now I have only 4 columns. Now, if you want to modify your answer, you can write into the chat box. Okay, so this is not the feature. Okay, I got the couple of response. Thank you. So now, as I mentioned in my first slide, it is the supervised learning. That means my data is labeled. That means in the last column is nothing but your target or outcome or output. So if you look at carefully the column name, this is not age, income, number of credit cards he or she having the credits, and class, whether it is a default or yes or no, whatever, or allied customer class, whatever, if you want to write. So this is nothing but this is your target. This is your output. This is your target. This is your output. Or you can say this is my labeled. This is also not a feature. It is just for a classification purpose. Now you can tell me how many features in this problem. Yes. Now we have number 1 feature, number 2 feature, and number 3 feature. That's it. So I hope this point is clear. I hope. So in this particular problem, okay, so keep in mind, whenever you solve the supervised learning problem, the last column is not at all the features. It is always a labeled or output type variable, right? Or most of the time in KNN, it is a classification, so it is a categorical type variable. Okay, I hope it is clear. Yeah. Now, what is the question? So the question is, I have some customer information, right? And in the last column, the customer name is Tapan, age is 37, income is 50K. he having the number of credit card is 2. I want to predict its class. I want to predict its class, whether it is the default class, whatever this. Okay. Default class, let's say. I want to identify. This is my question. How do we solve it? So as I mentioned that here we have already existing 1, 2, 3, 4, 5 data points. Whenever the new data point is come, it make an instance for each of the existing data point. It create the instance of each of the existing data point. Okay. Okay. So number one question in our mind is when you create the instance, first you have to define the value of k. So can you tell me what is the value of k in this particular problem? What is the value of k in this particular problem? Anyone? Just let me know what is the value of k. And my previous slide, as I already explained the value of k, the three important thing is minimum value, maximum value, and always this value is an odd number. So now you just tell me how many records you have. 5 or 6 records. Square root of 5 and 6 is what? 2 point something. But the minimum value is what? K. We have already defined the minimum value of k. In this case also we have a minimum value of k. Number one step. Right? Then this new data point is come into the picture. Then the new data point is come into the picture. Right? We need to create the instances with the help of what? Equality and distance. So first I calculate the distance from Tapan to NE. So how we can calculate? 35 minus 37 square plus 35 minus 50 square plus 3 minus 2 square. And this is the value. Like that. Then Tapan to John, George, Kevin, Tom. We can do this thing. And every points we, calculate the distance. Then the second step is what? We need to identify the nearest neighbors. So based on this distance value, if you look at carefully, NA, John, and the Storm, these three customers are nearest neighbor of Tapan. Okay, these three are nearest neighbor of Tapan. Once this process is over, what is the next step? Once you identify this, what is your next step? What is next step? You have to perform a voting kariye, and just let me know the answer, whether it is yes or no. Just can you give the answer into the chat box? We identify the three neighbors. Right? NA, John, and Tom. So we need to, vote. So NA class is no. Right? John class is yes, and Tom class is also yes. So majority of vote is yes. That means the Tapan class is also yes. Clear? I hope it is clear. Okay, so one question from Durga Devi ma'am. Why we take k is equals to, as I mentioned that, madam, in some literature also, we cannot take k equals to 1 due to the noise in data points or directly inherit that property of nearest data point, right? So we cannot take k is equals to 1. If you start with k equals to 1, then all of your data point is in the same quality. There is no classification exist, right? So it's by my iteration, we have three important things: is k is equals to 3 minimum value, second is k is odd value, and the maximum value of k is root of maximum data point, root of n data points. That's it, right? So I hope I think this example one is clear. Any confusion, just let me know. Example one, any doubt, any question? Okay. Move to the second problem. Now, I hope, just can you let me know the number of features in this given problem? In example 2, can you tell me number of features?
3, sir.
3. Okay. Okay, so the problem is the customer age. We need to find out this last row value. So the customer age is 48 and he have the outstanding loan amount is $1,42,000. You need to identify its class, whether it is yes or no. Right? This is my calculation. This is my calculation. This is my label data. Okay. So I have only two features, feature 1 and feature 2. Right? Okay. Okay. So just by mistake, I write the calculation directly here so that the confusion comes. Okay. Right? So the two features. Now, when this new data point is come, we need to create the instances. So how do we calculate the distance? Again, the Euclidean distance, right? And when we talk about the Euclidean distance, what happened? This distance is, majority of times it depend upon only this particular feature. Again, the step, so we go by the step. First, we need to define the key value of k. What is the value of k in this case? Can anybody tell me what is the value of k? K equals to 5. Okay. Please try once again. How many data point in this? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. 11 or 12 data points. 11 or 12 data points. If you calculate the square root of 11 or 12, it come out to 3 point something. So we cannot go for 4 because 4 is the even value. So we just lower half. So we'll choose in this case also the k is equals to. Okay. Now, second is I need to identify 3 neighbors. I need to identify the 3 neighbors, right? So the 3 neighbors are same. If you look at that in blue color in my screen, if you look at that, this one and that one. these are my three nearest neighbors. These are my three nearest neighbors. Now, what is the next step? We define the K, we identify the nearest neighbor, then we have to perform a voting. So one vote is for no, and two votes is for yes. 2 versus 1. 2 vote for yes, 1 vote for no. The majority of that's why I'll write answer is yes. Okay. But if you closely observe that in this particular problem, in this particular example, right, our distance value is depend upon only the single feature. That is the outstanding loan amount. But we have very important feature is age also. But my distance is only depend upon the loan value, not at all depend upon the age value, because its unit is very, very high. So to avoid these, situations, or you can say the problem, we converted into a optimum value, right? Or we converted this value into the normalization value. So how do we do that? If you look at that, the very simple thing to convert into the normalized value, right? To divide it to the maximum value, right? The entire column should be divided by maximum. So here 60 or 220. But we need small thing. Instead of v divided by max value, we have the small value. Instead of vi, we take the range vi minus v minimum divided by max minus minimum. So instead of that, we divide with not the maximum value, we divide it with the range value. So in the bottom right corner, we have a formula for the same. This AI is nothing but vi minus minimum value of vi divided by range. Range is what? Maximum to minimum, the difference between the maximum to minimum value. Right? So we converted both the features into the normalized value. क्यों कर रहे हैं? Why we do this exercise? Because in this current case, my distance is depend upon only the single features, whereas in our problem we have two important features, right? So we do the normalization. Okay. Once you convert this we have the normalization value, right? So 25. So we convert the 25 minus 20 is the minimum value divided by 60 minus 20 is 40. So 5 divided by 40 is 1 by 8 equals 2.125. So we convert entire value into the normalized value like that. Again, the same principle, same value to apply the K means AKNN. Same, very first step, K is equals to 3. Identify the 3 neighbors. So we have already identified 3 neighbors, 1, 2, and 3. Just a equilibrium distance formula, easily calculate. Once you identify the nearest neighbor, third step is the voting. So first vote is for no. Second vote is also for no. Third vote is for yes. Right. So out of 3, 2 votes for no. So that is the answer is no. But in earlier case, my answer is yes. Right. Okay. So when the unit is large, then my distances depend upon only the one features. To avoid this situation, we do the normalization. I hope it is clear. Any question? Okay, so last 4 minutes, I'll try to cover this exercise, this slide is by 2:45, and then we'll take up the question answer. Any question in example 1 or 2? Any doubt?
Sir, good afternoon, sir.
Yes, please.
Sir, can you tell me how to identify the nearest neighbors from distance? What is the
From? Okay.
You are identifying the nearest neighbors, how to identify them?
Okay, so sir, here also I am using the equilibrium distance formula. So this is the formula for the same. So 0.7 minus 0.125 square plus 0.61 minus 0.11 square, and then under root, this is a 0.7652. So I need to create the instance. So first I create the first instance, then the second instance, then the third instance, then fourth, 5, like this. So easily we can calculate. It depends upon the problem statement, right? You can apply any of the distance, right? And you can easily calculate. Right, sir?
Okay, sir. Okay.
Right? 0.7 minus 0.125. Okay, so xi is what? 0.7 minus 0.125 square plus yi is 0.61 minus 0.11. Right? So like that, you can easily calculate. This value is, when you calculate this, it is 0.7652. Okay. Like in my previous problem, if you look at that here, 37 minus 35. 37 minus 35, 50 minus 35, 2 minus 3. 35 minus 37, that is the 2 square means 4 plus 15 square, 225 plus 1 square root of 230 is nothing but 15.16. So very simple, sir. Normal, right? Any other questions so far? Okay. Okay, so now we come to the last slide. Okay. So what is the strength of KNN? Right? As I mentioned in my first slide, it is very simple. That's why the reason I have to, discuss this particular algorithm. It's a very simple and intuitive. The beauty of this particular algorithm is you can apply it in any data, any form of distributions. So the binomial distribution or normal distribution, any sort of data, you can easily apply this particular algorithm. It will give you the good result if the sample is very large, but it is a contradictory, or you can say there's a weakness as well. It will give you the good result, good accuracy, but at the same time, it will take a lot of time, right? You can say it is a weakness also. Take more time to classify a new sample. Why? Because whenever the new data point is come, it creates an instance for all existing samples. Need to calculate and compare distance from new sample example to all other examples. So for example, I have 1 lakh of record, and then if the new 1 lakh, 1 record is come into the picture, I need to, create an instance for the remaining 1 lakh record. Right. Choosing K may be tricky because if my data is large, is very large, let's say 10,000 samples, so the value of K is ranging from 3 to 100. So choosing K is tricky. It is a hit and trial method. You have to, calculate the accuracy. need large number of samples for accuracy, right? So this is all about your, K means clustering. Now I am open for the question answers. Still we have 10 to 15 minutes. Or if you do not have any questions, I'll ask some questions. No question? Okay, so suppose if my output variable type, okay, so one question by Durga Devi ma'am. In case of microarray data set, we have column is very, very much greater than rows. How to handle the such data? Ma'am, if suppose we have more number of columns, sorry, so that means feature 1, feature 2, feature 3, at least we have the records more than the combination of threes, right? Then only we have to train the record. Otherwise, if you have less number of rows, right, your prediction is not at all accurate. It always fall into the wrong category, right? So this is the thumb rule when we have the machine learning, when we want to apply the machine learning. Always the sample is very, very large as compared to. Otherwise, why you go for the machine learning programming? Okay. So basically in machine learning, if you look at that, basically our aim is to what you have heard about. We want to minimize our error. And how do we minimize our error? It is what? Your predicted sample minus your actual value, you have to reduce this difference. And this is nothing but this is known as the deviation. This is known as the deviation. But we cannot take this deviation in the actual values. Either we go for a mod of deviation or square of deviation. Why? Because in one case, my deviation may be a -5. In second case, my deviation may be a +5. So when I calculate the average deviation, this value is 0, or I can say that my system is work fantastic. But it is wrong. So either we go for modulus values, absolute value, or square value. But in both the cases, we prefer the square value. Why? Because our aim is minimize this error. And we know that when we design a system, our difference of prediction to actual is very small. So if I take the mod value of small value, it is the same difference. But if you have very small value, and you can take the square value of that, that value is also going down. So easily converge your system when you take the square value, right? I hope it is clear, ma'am.
Yes, sir.
Thank you. Any question? Pooja madam, can I conclude here?